All right, guys, so we're back. So the law of sines works really nicely for some types of triangles that are non-right. Law of cosines works for basically anything that the law of sines doesn't work for. So we'll write down what the law of cosines is. Now this one's a little bit different because if you look it up, there's actually 3 formulas. I kind of just basically memorized one version of this. So I'll write it down. So again, we have our A, B, and C. And again, our little a, little b, little c across from the angles that it goes with. Now this is going to look a lot like Pythagorean theorem, but I'm going to point out a couple things about it, but it's not the Pythagorean theorem because I'm going to add this because that kind of looks like it. It's not. So this is 2 times b times c, so those are being multiplied, times the cosine of a. So this formula, I could write this 3 different ways. The key is I wouldn't worry about the A, B, and C and where they are. The biggest thing is this is the side we either know or like the side we're looking for. And then this is the angle we like across from that side. Now, I'll show you guys in the book here. So they show it 3 different ways. So if it's little b, there's big B. If it's little c, there's big C. And the other 2 variables just show up in this formula. I like just memorizing the one version of it. I just think it's less complicated, but it's up to you how you want to think about this. So I'll show you guys how this works. First of all, this law of cosines is essentially, it's for when law of sines doesn't work. Because if I try to solve this problem by the law of sines, big C is crossed from little c. So I'll write that there. I don't know that. This angle is across from this side. I don't know that angle. I don't know this angle. So I would have too many unknowns in this problem, so we want to use law of cosines. Now, this formula, again, the side I'm looking for in this case is going to be little c. So I'll write this formula this way just so you don't get too confused. But so it's c squared equals, these are the sides I know. So b and c I should know. In this case, I know little a and little b. So I'll write it this way if it's helpful. But the angle I'm taking the cosine of is always the one across from the side I'm looking for. So that's what I'm working with here. So little c I don't know. So c squared I don't know, or you could call it x squared or whatever you happen to want to call it. The a and b are the sides I do know. So that's the 20 and 22. Minus 2 times those sides multiplied times the cosine of the angle I know. So everything's kind of substituted in. Now this is just a big, don't mess this up on your calculator type problem. Typically you can enter this exactly how it is in your calculator. Again, make sure you're in that degree mode. So if you happen to turn off your calculator and reset it, it probably went back to that radian mode. We want it in degree mode. So again, please be practicing this on your calculator. So we're adding those 2 values squared, then subtracting them all multiplied. And I'll tell you guys what I get, and then you can check yours. So I got c squared equals 960.697, essentially. Now, I'm going to take the square root of that to figure out c. So square root. So again, I just take the square root of my answer, so I don't really type that in. Start using that feature. That's kind of a nice shortcut. So I got 30.995. So actually it's probably 31. Because 30.995 would round up if we went to the nearest tenth. So 31. Now in this case, they only wanted to know that one side. So we're done. But if we wanted to figure out angles A and B now, we could actually use law of sines, and we'll do that down here. We'll do a practice problem where we find everything. But so now that we know that, we can use law of sines. Law of sines is a little bit easier for the most part, so typically that's the one I kind of default to. Now this next one wants us to find angle A. So rather than finding a side, because we know all three sides, I want to find the angle. So I want angle A. Now the important part is kind of what I talked about up here. So this time, I'm looking for the angle across from the side I know, so that's little a, and then that means these are little b and c. Whoops, sorry, that should be c, this should be b. So I'm gonna put all this into my formula, but this time I don't know big A. So I know little a is 10.4 squared equals, the other two sides I know, now to solve this is a little bit more of a pain because it requires a little bit more work. It's going to make us do some of this math. Now, you guys have to remember your solving equations rules. So essentially what we have here is this is multiplication, this is addition and subtraction. We have to move these away before we can just take this off. Because think of it, if we were trying to solve a problem like 5 equals 7 minus 3x. We would move this 7 over first and then divide by 3. So picture this as being our x. We're trying to get this alone. So you have to remember your rules of like order of operations with solving. So what I'm going to do is basically square everything and multiply everything. So I'm going to try and do like a bunch of math here to simplify this up a little bit. The numbers are going to be kind of huge, so just bear with me. So I'm going to do 18 squared plus 21.9 squared. And then multiply these together. So again, this is all being multiplied to cosine of A, so I have to move this over first before I can, I can't combine those two together just like I couldn't put those two together. So I'm gonna move this 803.61 over. Whoops, it cancels there, it doesn't cancel there, sorry. Don't let it scare you that this is a negative, that's okay. That color's hard to see, I think. And this is a negative 788.4. Now I'm trying to get A alone. So this is being multiplied, so now I'm going to divide by that 788. That negative 788. Oops. So when I divide those two, I get like 0.8821 kind of. Now in order to solve for A, this is where again I do my inverse cosine of that answer. Again, I won't retype this, I'll just do inverse cosine of that answer. And I got like 28.1 for that angle. So angle A is 28.1 degrees. And if you look at my drawing, that kind of makes sense because this should be the smallest angle. So it's a pretty small size. Like if I got a really huge angle, I would kind of question it because it's across from the smallest side. So that's 28.1 there. So when you guys have to do problems like this in your homework, maybe follow through the steps as you go here. Then this last one asks us to solve the triangle. That means find all the missing sides and angles. Now, again, when I'm starting this one off, 88 is across from little b. I don't know little b. A is across from 17. I don't know big A. And C is across from 30, and I don't know big C. So in this case, I'm going to do law of cosines first with my B, because of the fact that I don't know little b, but I do know this angle and I know the sides around it. So I will kind of point out, if you guys remember when we talked about like side angle side, anytime you have side angle side that you know, I know a side, the angle between another side, law of cosines is probably the one you're going to end up using if I didn't tell you what to use. So I'm going to modify this formula if you like seeing it this way. Now the b squared is what I'm starting with because that's what I don't know. Then the other two sides are the ones that, oops, not that, sorry. So the other two sides, I'm going to be my A's and C's here. So this is A, this is C. But now the angle that I'm using is cosine of B because that's the angle I know. So I don't know little b, but I know A and C. Now this is the one that is really just a matter of putting this into your calculator correctly and not messing anything up as you're typing. On my calculator on my computer, when I hit backspace, it deletes the whole row. So I can't make mistakes. All right, so I got b squared equals 1153.4025. Now again, I do the square root of the answer here. And I got B is 33.96. So it's the nearest tenth, so that'd be 34. So this is 34. And that's a side length, so it's not degrees. Now, once I know that, this asks us to solve the triangle. So there's a couple in your homework like this where it says to solve the triangle. I'm going to redraw this just because this is a bit of a mess. So I have 88 goes with 34. Sorry. It's not on your screen. 30 should go with C, and then A should go with 17. So now I need to find either A or C. It doesn't matter which one you go for. So I'm going to go for angle A here. So now I'm going to do law of sines. Sine of A goes with 17. And then now I know this sine of 88 goes with 34, right? We just figured that out. So kind of going back to what we just did on the front side of the paper. I could have also found angle C before, or right now if I wanted to, then it'd be sine of C over 30. So now I'm going to cross multiply. Oops, if I could use my 8s here. And then to get this alone, I'm going to divide by 34. So I'm going to do the inverse sine of this whole thing. Now you could figure this out first and then do it. So like I'll do that. So 17 times the sine of 88. Close the parentheses, divide by 34. And so I'm doing the inverse sine of something really close to 0.5, 4997. So inverse sine of that. And I get like essentially 30 for my angle A. So angle A is 30. And so angles should be degrees. Now that I know angle A, I can find angle C because they add up to 180. So 30 and 88, take those away from 180. And that should be 62 degrees for angle C. And you should have gotten the same thing had you done law of sines. So hopefully either way that you went about it, it should work that way. So you will have a worksheet that you will get for the Miss Miller or the sub or whoever is there with you. And hopefully you guys can use this to help you. There are questions like the warm-up as well. So hopefully I'll be back with you guys tomorrow, but if not, I will ask for like a list of questions that I can do like a video for you guys on that. Hope you guys are all well. We'll talk to you soon. Bye-bye.